Welcome to Antenna by Panda. This time we have 70 centimeter Yagi antenna, 3 elements Yagi, designed for the 450 megahertz band on the UHF. So let's check the antenna configuration. For this build, I use a bigger U-bolt to accommodate the client's request. I have put the markings on both the elements and the markings on the boom, so you just need to put back the elements with their corresponding numbers on the boom. We have a gamma match Yagi with an SO239 feed point. We have the tuning stub. This is positioned at the bottom of the gamma match, so I'm just going to put marking tapes. So you just need to put back the tuning stub in between those marking tapes. We have a PL259 connector at the back connected to the coaxial cable, an RG8 coaxial cable going to my nanoVNA to check on the frequency response. The antenna is intended to be used on 454.230. So as we can see, we have 445 megahertz, the bottom of the frequency, and 458 megahertz, the upper frequency. We intend to check the SWR on 454.230 or 220, but the nanoVNA cannot precisely read out the exact frequency because of the resolution of the nanoVNA unless I plug it into a computer. So this is acceptable because the antenna will be used on 454.220 megahertz. On this frequency, we have a 54.7 ohms SWR impedance. We have the frequency of 454.230. We have a 54.2 impedance, and capacitance is around 17 picofarad. The SWR is 1.4 or 1.5 with antenna return loss or log mag at minus 14.21 dB. The exact dip or the lowest dip on the curve, as we can see here, is around 451 or 451.2. So it's 451.2 at 1.02 BSWR. So the lowest frequency SWR is at 1.6 or 1.59 at 445 megahertz. The upper frequency or the uppermost frequency SWR is around 458. Then the SWR is 1.53. So we have an SWR of less than 1.5:1 on the intended frequency. This antenna is pretty usable as requested by my client to produce the antenna on 450 megahertz UHF frequency band. So this antenna is ready for shipping. Thank you for watching, and until next time.